Hello everyone, welcome back. In this video, we're going to get started with OpenCV. OpenCV means open source computer vision. Today, we are learning the basics. You need to visit my GitHub account and then copy this repository to go and clone it. For me, I have it cloned. But if you don't have it cloned, you will do git clone. Then you paste. Okay. For me, it says it's all there. Also, another requirement before we start today's lesson, you need to check if you have OpenCV installed. You can open Python and check if OpenCV is installed by importing it. Yeah, it's imported. It means in my case it's installed. You can even print CV2 version, the double underscore version underscore, you close the bracket, then exit. Well, it's well set on my side. If you don't have it installed, don't worry. There are instructions on how to install it. You can copy this link, I mean this command, and paste it. Because it's installed, the requirement is already satisfied. And even if I try to install a headless version, for me, or is installed. I hope it's installed on your side too. And if it's not, you can start by making sure you get it installed, and after the installation you verify that you have it working. Okay, so we have this tree. We have this folder and we have files inside this folder. So let's navigate inside the folder basic operation. Okay, this is it. We have 10 operations that we're going to discuss about today. We're going to discuss about reading and displaying image, resizing image, converting image to grayscale, drawing shapes like a rectangle, circle, or both, cropping the region of interest, flipping the image, saving the image into different formats, blending the images, adding text to an image, splitting and merging the image channels. These are 10 operations that we're going to run, and all these operations are considered basic in OpenCV. In the coming videos, we'll be discussing about more operations from simple to complex. Okay, so let's start by reading and displaying the image. Let's first look at the code. Here is the code. In the code, we started by importing OpenCV, and then we load the image lina.jpg in the memory using the function or the method imread. And in the memory, the image is saved in the variable image. This is a copy of the image. It's different from the image or the copy, original copy saved on the hard disk. And then imshow is to display the image. Imshow accepts two parameters. That's image window. This is a text this is the name of the window, and image, it's the same variable that holds the image or the image copy in the memory. And then we have another function, wait key. Wait key is for waiting for any key to be pressed. It means the window will be displayed as long as no key is pressed, and when the key is pressed, that's when this function destroy all windows will work and any open window will close. Okay, this is the code. Let's run it. Okay, this is the name of the window, image window. And this is the image. I press any key and it's gone. Let's go to the next operation, image resizing. Let's look at the code. In the code, we started by importing the library. We use imread to load the image in the memory and saved in the variable image. Then the image is resized. Resizing in this case it's being divided by 4. It means the width, which is shape 1, is divided by 4, and the shape 0, which is the height, is divided by 4. So both width and image are divided by 4, and the variable the resized image is saved as in the variable called resized image. Remember, the original image is not touched. It's intact. It's still there. We are just manipulating the image, the copy of the image that was loaded in the memory. We can decide to show it by imshow. image show, the window is called resized, and what we show on the window is the just resized image, and the image will be displayed, or the window will be open as long as any key is not pressed. But once any key is pressed, the image will be saved as linear resized, and then all the windows will be destroyed. How many functions? Imread, resize, imshow, white key, imwrite, destroy all windows. Okay, let's run the code. Okay, this is it. So when I press Enter key to exit. Let's run the operation 3 convert to Grayscale. Let's first look at the code. Code 03. Here is the code. We started by importing the library, the OpenCV, then load the image, imread that accepts one parameter, or that takes one parameter linear, the image, or as saved on the directory, and this is the function CVT color. This CVT means convert, and it accepts two parameters. The first parameter is the variable of the image, and the second parameter is this property called color underscore BGR to gray. BGR means blue, green, red to gray. Okay, and there's the function imshow. This is the imshow to display the image, and we are displaying a grayed image, and it will be displayed until any key is pressed, and when any key is pressed, it will write to save the grayed image as linear gray.jpg, and all the windows will be destroyed. Let's run the code. Okay, linear now is gray. Any key pressed. Operation number 4, we're going to draw shapes. We'll draw first a rectangle, then a circle, then both. So let's look at the code, the first code to draw a rectangle. Call 04 underscore 1. Image library, first library loaded, image load in the memory. Then this is the code rectangle to draw the rectangle. It accepts the following parameters: 1, 2, 3, 4, 5. How? The image is the copy of the picture that's loaded in the memory, and the second is the top left corner, and the third parameter is bottom right corner. You understand the rectangle has top left corner and bottom right corner, and this is the color. In this case, it's BGR. So this is G, this is green, and this is the thickness. It means the boldness, the kind of line width. Then this is to show the image. Remember, it's the image on which a rectangle is drawn, and it will be displayed until you press any key, and when you press any key, the image and the shape drawn on it, or the image with the shape drawn on it, will be will be saved to the memory, to the hard disk, and then all the windows will be destroyed. This is the code. Let's run the code. Okay, this is what it means. This is the top left corner, which is 750 XY, and this is the bottom right corner, which is 1500 for X, 1500 for Y. Okay, this is the rectangle. I press N key to exit and go to the next operation. The next operation was still drawing. Let's now draw the circle. Let's look at the code first. Okay, it's similar to the code that draws a rectangle, but this one is drawing a circle, and this function circle is a little bit different of rectangle or rectangle method. It accepts image, it accepts the center. This is the center, and the radius, and BGR, and this red, and this is the thickness. Okay, we can run in the code. Other functions remain similar. So let's run the code. This is what you get. I press any key, and then I go to operation number 5, cropping a region of interest. It's you who defines a region of interest. In my case, I selected the face of Lina as region of interest. Let's look at the code. Code 05. Okay, so I looked at the face and found out that these parameters fit the face of Lina. So to crop the image, this is Y, and this is X. Y means height, X means width. So I'm going to take Y, to consider Y, from 550, this is Y, the height, from 750 to 1500. 750, similar, so this will be a square. Okay, so the other functions remain the same: loading the image in the memory and cropping the image in the memory and saving the cropped image in the variable cropped image and showing it on the window, displaying that window while waiting for any key to be pressed, and when any key is pressed, exiting, but before closing, destroying the windows, you write the cropped image as Lina cropped on the hard disk. This is the code. Let's run the code. Okay, this is what's cropped. I press N key and exit. We can draw. Before we cropping, we can draw something. We can draw. Then after drawing shape, we crop. It takes both what we learned in operation number 5 and operation number 4. So let's look at the code. Here, cropping happens after we draw a rectangle and a circle. I explained how to draw a rectangle, I explained how to draw a circle, and I explained how to crop. And then the other functions remain the same. So if you run the code, it first draws the rectangle, green rectangle, then red circle, then crops. And I press N key and this file is saved. You can find it saved here. Where is it? Is it saved here? Azulina cropped. This. Okay. So what's next? Let's try and flip the image. Let's look at the code. Code 06. Here is the code. Similar. Or start by importing the library, loading the copy image in the memory. Then flipping, we just use the function flip. Then, yeah, one means horizontal. So let's flip. Let's see, or let's run the code and see it flipped. That's Python 06. Yeah, it's flipped. As you see, you can see that Lena is flipped now. And let's try to make another flip. I press any other key in any key to exit. So let's modify the code. Let's put 0 and see. I run the code and see 0 is flipping. Do you wonder if it 2 can do anything? Let's put 2 and see what happens. Yeah. It is still flips horizontally. And you wonder if I put 100, what will happen? Same. What do you think? We have a 0 and 1 or more. 0 means vertical. 1 or more is horizontal. That's flipping. Any other operation? The image can be saved into different formats. So let's look at the code. In this code, we don't have any new function. We have imRead, you know it, imShow, to show, wait. But at the time of saving, we can save as PNG, as BMP, you can save as JPG or JPEG. So this is what it says, and I don't really think we need to run in this code. There's nothing new, but saving in the different format. But if you run the code, what you just get is the image saved into different formats. Let's try it. We have it. I press any key, and when we check, we have Lina image.bmp, Lina image.png. Yes, that's what it means. Okay, so let's blend images. I first of all, I would like to show you the images that we going to blend. Let's first look at the code. Code 08 blend. We're going to blend a fish, a pig, and a fish, and the result will be a fish. Let's look at the fish. We have this fish, and we have this pig. Okay, and what we are going to do is to blend them. This is the code to blend them. The function to blend is add weighted that accepts 5 parameters. The first parameter is image number 1. The second is the weight. The influence of the image, they share the weight. So every image has equal influence. Yeah. The fifth parameter means the brightness. 0 means we didn't change any brightness of the blended image. Okay, so here we display a blended image until a key is pressed. Then we save a piece and destroy all the windows. Let's run in the code. Here is the piece. Okay, that's beautiful. I press any key and again, let's see how to add a text or on the image. Let's look at the code. Let's look at the code. In the code, we have put text. Put text accepts the following parameters. The first parameter is image, which is the copy of image loaded in the memory, and then the text to write, the position at which the text will start, and then the font family, and this is the font scale, this is the color of the font, and this is the thickness of the text. Then we show the image text. We wait until press any key, and then the text, the image with text will be saved, and all the windows will be destroyed. Let's run the code. Here is it. Let's make some modification and see how it affects the text. For example, let's try to play with the scale. Let's make it 10 instead of 5. This is how it affects it. you can see the scale, and what if we make it like 2? Can you see? Small. And 4. You can see. And then let's play with the thickness. This text is a thick, but let's make the thickness 10. Less thick. And you can even make it less. Make it 6. Okay, so this is it. That big thickness, not thickness. 20. Really thick. And you can scale the text to something like 6. Okay, this is it. And the last but not the least is splitting and merging the channels. Let's look at the code. Let's look at the code. In this code, we start by importing the CV2. In this code, we have a new library that's NumPy. Sorry, I didn't tell you to install NumPy, but we need it for this code, this operation. Other operation remain the same. We load the image in the memory, and we run the split method. Split returns 3 variables or 3 values, and of course in the array, the first value will be a blue for blue channel. The second value will be for green channel. The third value will be for the red channel. And this is where NumPy will play a role. It will extract. We need this function merge, and we need the function is like from NumPy. So this will only extract the blue channel, and this will only extract the green channel. This will only extract the red channel. And the following code is for showing, a kind of slideshow, because we need to display an image or a window for every channel. Blue channel needs its window, green channel needs its window, red channel needs its window. Then there will be a slideshow separated by the interval of 2 seconds. Then this is how we show each slide, and each slide will end. This is not really wait key. This will act like wait key, but the wait key here, or the kind of key press is not a physical key press, but it's the end of this interval of 2 seconds. And then we go to the next slide, the next slide, until all slides are done, and or 3 slides are done, and then that's when we'll save all these channels into a single channel, like merging them into a single channel, and the single channel will then be shown under the window merged image scrubbed. This is where all the channels will be merged and shown, and then when you press any key, all the windows will be destroyed. Let's run in the code. The first channel, second channel, third channel, then the channel in which all the channels are merged or scrubbed. And when I press any key, all the windows will be destroyed. So that's it for today. But before we close, there's an assignment. I have an assignment. I want you to write Python code to annotate the image file known as assignment 001 given, so that it looks like the image file assignment 001 result. Those are assignment 001 given. You are given this image, and you're going to write Python code so that your code draws this rectangle and writes this text, and there is this transparent background behind the text. So this is the assignment at the end of today's lesson. And remember, you have everything here. You have the code. What you don't have is the code for the assignment, of course, because it's the assignment. Okay. So I hope you learned something. This is just the beginning, and you can imagine how the next videos will be so exciting. So bye, see you in the next videos.